Welcome to the Crazy Hat Chemist. So another video here on kinetics. So let's get started with this one. Bam! So today we're talking about a progression of a reaction graphically with and without a catalyst. Very important here. So I'm going to delineate all the parts of this graph here. So take a look at this graph here. So on the far left-hand side, we've got energy. That's on our y-axis. On our x-axis, we have the reaction coordinate. So this is an energy versus reaction coordinate graph, if you will. Okay, so I'm going to delineate a few more points here. On the far left-hand side, it says reactants. That's that line there, where the red and the blue lines are kind of together, flat on top of each other. So on the left-hand side of this are reactants. I've circled that there. On the far right-hand side are the products. Notice that in this particular graphic, the reactants are higher than the products. That's going to be an important point here later on. There are other graphics where the reactants are actually, so they're here, the reactants are higher than the products. You can have the products higher than the reactants, and that's okay too. Two different types of reactions. When the products are lower, that means it's exothermic. When the products are higher, that means it's endothermic. Okay, exothermic is heat liberating and endothermic is heat requiring. So those are the differences between these two places and the positions of where the reactants and the products are. So you want to pay particular attention to that. Okay, the activation energy barrier, that's the minimum amount of energy required for this reaction to go from reactants to products, is called the E sub A, or the activation energy barrier. And I looked over that and I went over that in the previous video. Okay, so without a catalyst, I've delineated this with this double-headed arrow in the red. This is the high point of the graph and then where the reactants are. So you're going to start off where the reactants are, and then you need to overcome this hill. At the peak of that hill, when you reach the peak of that hill, that is the activation energy barrier, because you need to go over the hill. So as long as you reach the peak of the hill, then you've reached that activation energy barrier. That is without a catalyst in the red graphic line there. So that's what that is. Okay, now look at the blue graph. The blue graph has a lower activation energy barrier, and that activation energy barrier is lower. So from the reactants, notice that the reactants start off in the same position with or without a catalyst, and the products start off in the same position with or without a catalyst. But without a catalyst, you have a very high activation energy barrier. That means it requires a lot of energy to overcome that barrier. With a catalyst, what it does is lowers the activation energy barrier, but it doesn't change the position of the reactants or the products with or without a catalyst. It's very important to note about this. Okay, a couple other little points here is that very top part of whether it's with a catalyst or without a catalyst is the transition state. So the very top part of this graph, okay, the top of the activation energy barrier is called the transition state. And that is when the molecule or molecules are in their most stressed, strained conformation possible. That is the highest energy possible, okay, is at that part. It's just like when you're trying to climb a mountain, you have reached the peak of the mountain. That is the highest energy that you can possibly reach. After that, it's really all downhill, as they say, from there. Okay, so the difference between the products, where the products are, and where the reactants are, is the release of energy, okay, or the absorption of energy if the products are higher than the reactants. But in this case, they are lower, so it's a release of energy. That's because this is an exothermic or heat liberating reaction. Okay, hopefully that makes sense. That's what that line is. All right, so I'm going to give you another graphic, and this one here is a multi-step catalytic reaction. So notice that the activation energy barrier without a catalyst, the black line, okay, is very, very high. Okay, you start off on the reactants, which is the X and the Y. The product is the Z. Okay, and then the red graph is the activation energy barrier, and this has actually not just one activation energy barrier, but multiple activation energy barriers. Each one of those little peaks has its own activation energy barrier. So we have activation energy barrier 1, 2, 3, and 4. So this is a 4-step catalytic event. Okay, now you don't sum up all the little humps there, but the highest peak there is the highest activation energy that you need to reach. But it's a multi-step catalytic reaction. This is much lower in energy than that total black line. So the red line, even though it's multi-step, it can still happen at a much faster rate because you've lowered the amount of energy necessary for this reaction to proceed forward. Okay, this one is also exothermic here, and that means that the products where the Z is lower than the reactants with the X and the Y. Okay, that is the basics of a graphic of the catalytic reaction here. Hopefully you've enjoyed that. Okay, I got a great hat here for you. I just found out that one of my teachers actually bought a giant stuffed animal. It's like 6 feet high, and what is it of? A giraffe. And fun fact about giraffes is that they have a tongue that is about 7 inches long, and it's black so that it doesn't get sunburned while their tongue is hanging out grabbing all those leaves so they can eat. Give me a thumbs up if you like that video, subscribe to my YouTube channel, pass on my website to all your cool chemistry friends. There's all kinds of information on my website. Worksheets, more videos, all organized according to unit. I'll see you next time for more cool chemistry videos. Bye for now.